Okay. So this is the demo session for AI and ML. So in this
Okay.
demo session, we are going to walk through various aspects within AI. Meantime, you guys can mute out. Okay. Just mute your call so that it voices there's no disturbance in the background. So we'll go through the introduction and then we'll look at the interesting facts, industry trends, and most importantly, we'll look at why now, why AI now, though it has been for a long time now. Then we'll look at applications of AI, few components of AI, and where exactly you can fit in AI. Okay. And then finally, we'll walk through a few demos on the GUI tools or the IDEs and see how exactly the program would look like. And finally, we'll follow with the Q&A session. Now, first thing is with regards to data, this is known as a new oil of the digital economy. And the reason why we call it as a new oil of digital economy, if you look at even in a country like India, Reliance has shifted its focus from oil to digital economy, and they are heavily investing on that. Probably they have really understood, what is the future, and definitely they will have a brighter side if they get into digital economy, and that's why Reliance is heavily focusing on AI. Apart from this, if you look at Dubai has appointed a new AI ministry last quarter of 2017, and that ministry is specifically focusing on only AI. And this is first time in the history where a country has appointed a specific ministry with regards to AI or artificial intelligence. Then the other interesting fact is if you look at Google, earlier during the last century they were focusing on mobile first, and now they are focusing on AI first world. And by 2020, it is expected that most of the customer services will have voice and face recognition within them. Okay, and millions of stocks are transferred on a monthly basis. If you look at, there are around 5 million stocks which are actually transferred on a monthly basis using AI. And another important or interesting fact is the Shanghai airport, which is in Singapore. It has no human interaction. Right from the your entry, your check-in, your security check-in, boarding, and your clearance, everything happens automated. Everything is automated. So that's the kind of future or the world we are really looking at. So AI has really been extensively helpful to implement these kind of solution at a vast scale. And China, if you look at China, they have actually stated that by 2030 they will be world leaders in AI. Okay. And if you look at the Boeing flights, only 7% of the Boeing flights is actually manually operated. Rest of 93% it's all autopilot. And a lot of AI also is involved in that. Okay. And there are a few more other interesting facts, but I'll just go with one or two out of this. Now, if you look at AI, where is AI today? If you compare AI with a human, it is equal to a 4 years old human baby. Okay, and by 2028, it is expected that it will be as intelligent as an adult human brain. And probably the estimation is in that in next 22 decades, it will be as intelligent as compared to the entire human race brains combined together. So that's the kind of future or the power which we are trying to leverage from AI. And now if you look at the company Alphabet, which actually owns Google and YouTube, uh, now if you combine both the revenues of Alphabet and Facebook, their combined revenue is more than half the world's revenue of internet advertisement. And the reason behind is they own the data. So as long as you own the data and if you can do a lot of AI intelligence on it, definitely those are the people who are going to be the market leaders, and that's where Alphabet and Facebook stands today. Apart from that, here are a few other numbers with regards to the data, the amount of data which is being transferred on a regular basis. If you look at Facebook, it actually processes around 10 petabytes of data per day. So that's quite huge comparatively. So let's move to the next slide. Now here we are just showing you the revenue chart with regards to AI in US dollars in millions. From 2016 to 2025, if you look at the increase in revenue, which is almost 43 folds of revenue increase in the AI segment, and 43% is quite a good sign, or the kind of statistics which we are really looking at. Then let's look at some market dynamics, impact on current job profile across industries. A lot of industries would be really impacted with the invention of AI. If you look at automotive repetitive tasks, then cloud infrastructure, automated testing, then automated cars, virtual assistants, and industry robots. Even during my career, I was working as a program manager. We saw a lot of changes within the resource handling and how things were going on. Definitely, we in last 2 years we have seen a lot of impact on the testing teams. There is a lot of reduction of manual testing, and most of the stuff was getting automated. We could actually see that happening, and it is estimated that by 2020, this would actually kill 5 million jobs. So that's the kind of impact it is going to make on the market. So probably most of the market dynamics would change based on this. Then, if you look at employment market in the future, so probably Ranjan, this would really help you out. So basically, till now we had a different kind of a working model, and probably this is soon going to change. And why it is going to change is because the new age workforce would definitely need good communication skills. They need to be multitasking. They have to be quite innovative in their thinking. They should be constant learning and upgrade their skills on a regular basis. They have to be diversified. Now, why we are saying all these things is because earlier you had a regular employment, okay, and probably in near future this is going to change because of the dynamics of the market, because the market is probably going to change every 2 to 3 to 4 years. So definitely, having a long-term employee doesn't make too much of a sense. So that's why freelancing or contract employment really comes into picture. This is the part we are talking about. So if you look at last 2 years, even in companies, we had already started these activities. Or in most of the projects, we used to have 20% of contract employment. So that's the kind of future we are looking at. So that definitely I think we need to plan for this kind of employment in the future. Okay. Now, let's look at few other statistics. We'll not go to all this, but now if you look at a lawyer's profession, he would probably deal with 4,000 or 5,000 cases on an average during his entire lifespan. Okay. Now, assume that the same system is transferred to artificial intelligence. Now, artificial intelligence, you have to train the artificial intelligence. Probably you would, feed millions of records into it so that, it can be trained well. And assume if an system is trained with millions of record compared to 4,000, 5,000 cases, the kind of experience gap which really forms in. So definitely you can expect excellent results by using AI as long as you have good data to be consumed with it. Probably similar approach would be, for most of the other industries it will follow. Now, definitely there are few loopholes within AI, but they definitely I think we will overcome in near future. When you compare with a human have a tendency to resolve novel situations. Okay, so when I say a novel situation, for example, you take Percy Spencer, who was actually working on a radar during the Second World War, and by mistake he kept a chocolate near his machine, and the chocolate got melted. and he was quite interested in cooking, and he knew a lot of cooking. So he immediately could connect that why don't we get cooking into microwave? Why can't we do cooking with microwave? That's how he started connecting things, and that's how the microwave was invented. So this is one of the kind of a novel situation. Similarly, in tax restructuring and a lot of other areas, you have a lot of novel situation problems where I think machine is not really that intelligent at this point, but definitely it will surpass in near future. Okay, this is a basic comparison between technology versus human here. Let's go to the next slide. So I'm being pretty fast because it is overnight. So I'm just quickly going through this. So these are all the basic verticals within the industries, and the ones which are in bold, sorry, are the industries which are heavily dependent on AI. For example, finance, healthcare, automotive and transformation, and legal advisory. So these are verticals or the industries which are heavily using AI right now. And definitely there will be other industries which are following behind this. So in most of the industries, definitely it is going to come soon on that. Okay. Then this is the further division with regards to major areas within AI. You have autonomous robots, digital assistants, neural computers, embedded systems, and expert systems. This is just for the facts and figures. Okay. So then I'll move to the next slide. Now here we'll just quickly look at history of AI. Now the first word robot was coined in one of the plays in London. That was in around 1923. And the actual first word of AI was coined by John McAtee in 1956. Okay. Then few years followed, and most of the work was done during 1990s with natural language understanding, translation, gaming, virtual reality. Most of the work was done during 1990s. And probably one big achievement or a milestone for AI was when it actually bet Gary Kasper in 1997. And this was one of the solutions which was designed by Big Blue, IBM. Okay, so this is the kind of history which we had. Now let's look at why artificial intelligence now, because probably if you look at this history, it spans to almost a century, but now you see a lot of activities going around AI. What is the reason behind it? Probably there are three basic reasons. One is with regards to processing. So earlier we used to have CPUs. Probably during 2012, GPUs were invented, and definitely this increased uh, the processing speed because CPUs are mostly focused on the system and the system administrative tasks, system sharing, and all that stuff. But GPU are more dedicated to a specific task, and that's the advantage we gain, and they're much faster than CPU. So definitely a lot of processing power, we had, which we could leverage. And then data, we had a big revolution of big data during the last century. So a lot of data is behind the scenes. It could be images, text, the mapping data, a lot of other data, structured data, unstructured data. So there's a lot of data which was gathered during this time. Then the other advantage is storage. Uh, if you look at storage per unit, the price has drastically reduced and the capacity has drastically increased. So these are the three prime areas: processing, data, and storage, which actually helped AI to kickstart and start giving results on that. Probably till last century, it was all mostly theoretical, but most of the implemented kickstarted during 2012, mostly within even deep learning, by the invention or upgrades within this processing data and storage. That's the reason why AI is quite hard in the market, and probably it is at a very early stages, and there's a lot of future within it yet to come in. And these are all major solutions within AI. Probably medical industries with regards to imaging or prediction of a particular disease based on the genes. So there are a lot of activities happening within medical line. Then you have a lot of activities happening within banking sector. Probably you might have seen this uh, driverless cars, which are automated auto driving cars. Then we have Facebook. It uses a lot of driving for sorry, a lot of image detection activities, and for emails, a lot of spam emails and all that. This is an age-old solution within AI where you detect a spam, and probably one of the basic examples which is done as part of your program. Then Amazon heavily depends upon AI. A lot of gaming is also taken into AI. Uber, Ola also uses a lot of AI to predict their customers, behavior and exactly where the calls could really come from, what the price should be. So a lot of AI is involved within these most of the components. And this is one of the best inventions which even I could find was the Sophia robot. If you have heard about it, well and good. Otherwise, I can just quickly show you the stuff. Now, this is a selfless driving car, which is actually designed by Audi, and okay. And if you look at this whole stuff, this car is driving by itself, and this person is actually a humanoid. So her name is Sophia, and she's been part of a lot of studies with artificial intelligence. And she even with if you look at her face expressions, she can already give 63 facial expressions. So that's quite amazing comparatively, and a lot of emotional aspects have also been added to it. Okay, so these are the kind of inventions which are going within artificial intelligence right now. So we'll just get back to the stuff. Okay, then let's look at quick buzzwords. We keep hearing a lot of stuff about that data science or big data. So let's quickly look what these terms are. Now, data science is not a technology; it is actually a domain. Your big data, artificial intelligence, machine learning, all this stuff falls under data science. It is an abstract word which sits on top of all of these technologies, and most of the technologies fall under data science. Big data, yeah, it is homogeneous, voluminous, and complex data where a traditional database cannot handle. Uh, Big data can handle structured data and unstructured data. It could be voice, text, or it could be videos, images. So it can combinedly handle most of the data and process them at much faster speeds. So that's where a lot of systems like Hadoop and other systems come into picture. Now let's look at AI. Now, if you look at this diagram, we have artificial intelligence, we have machine learning, and we have deep learning. Deep learning is a subset of machine learning. Machine learning itself is a subset of artificial intelligence. Okay, so this is how you could actually compare these three terminologies. Okay, so normally during the course we'll go in depth into each and every aspect of this, but here we're just trying to show you, where each of these component really stands, or how they are actually related. And this is another basic diagrammatical flow of entire data science. This is the complete data science. Within that, you have statistics, you have data visualization, we have artificial intelligence, we have big data, and all these are somewhere interrelated to one another. Okay, probably artificial intelligence might need a lot of data, which could come from big data. It might need a lot of visualization tools here, like Tableau and a lot of other tools. And statistics is the basic component which is anyway involved in uh, uh, artificial intelligence or machine learning. Okay. This is the other way of representing the same stuff. If you look at AI, big data or data mining or data science, probably most of the stuff is all overlapped on one another. Okay, as we said, if you do deep learning, you need a lot of data. That data can be actually organized and managed in big data, probably a system like Hadoop. Okay, and data mining is also part of data preparation and other activities. So definitely they will have somewhere or other some overlaps with different other technologies. Probably here another technology which is not mentioned is IoT. So you can actually, have put a one more cycle here and put IoT in that stuff, where it will also have some overlap on artificial intelligence, and it can have an overlap on big data also. Okay, so let's go to the next slide. Now here we talk about roles and responsibilities within the data science. If you look at majorly, they are categorized into three different areas. Okay, this circle actually is more to do with the technical stuff. If you are in SQL, if you are into security, managing secure user database security and all that stuff, or doing programming either in Python or any other language, all that stuff falls under this particular circle. And this is the one which is more to do with statistics. And finally, this is more to do with the business side of it. Probably most of the business users or functional users, most of them fall under this umbrella. Okay. Now there is one famous role which we keep hearing on a regular basis, which is the data scientist role. Now the data scientist uh, probably is the one who has knowledge in all these areas. He definitely doesn't need to be an expert, but definitely he needs to understand how how these things can be interrelated to one another. Okay, that's a quick description of different, basic roles. Apart from that, there are a lot of other roles, probably, project management role, or it could be admin role, or it could be an ETL role. So there are a lot of other roles which might not be directly related to machine learning, but definitely it could be part of your data extraction, data preparation, a lot of other activities which are involved in it. Okay, now let's go to the next slide. So here there are few tools which we have tried to highlight, and during the course we'll work with some of these tools. Okay, so we'll just go with a set of these tools, exactly what these tools are. Uh, One set of tools what you have is GUI tools, graphical user interface tools, where you would not really do much of the coding, but it's mostly drag and drop. So RapidMiner is one of the world leaders in that with regards to data analytics or ML or AI. So this is one tool normally we will use in course. So this is one good tool which is available. Apart from that, there are a lot of tons of other tools like Weka or Azure ML or Amazon Cloud. You get GUI. So there are a lot of other companies like Google is also working on GUI. Soon they will launch their own platform within for this machine learning GUI. Okay, so this is one set. So within this we will work with this part. Then there's one other set which is the programming part. You will have Python, R, Scala. You can also do programming for ML in C++ or Java, most of the other languages, but the most predominant language which is currently prevailing in the market is Python. So this is the language which we will normally work through. Then any project or IT project has to definitely have some database backend. So these are probably the database which will normally be used. It could be Hadoop or MySQL. So probably we will be connected to MySQL. Then you will have a lot of data visualization tools. Probably most of the industry guys use Excel, but Tableau is another one interesting tool which is heavily used in the market. And this was the tool actually even we used in our project. In 2006, actually, we worked for Electronic Arts, where we developed a data analytical project for around 25 terabytes of data. So there for data visualization, we actually used Tableau. It was an excellent tool. So whenever you have time, just go through this tool. This is an excellent tool. Apart from that, you will have TensorFlow and Theano. TensorFlow is from Google, and this is quite hot in the market. And during the course we will focus on TensorFlow. Okay, but apart from that, there are other solutions like Theano and all that, which actually are the new numerical computer library, which uh, which actually helps us to work on CPUs and GPUs. Okay, so these are the fundamental basic tools which are currently prevailing in the market, and few of them which we will actually use in the course. Okay. Then there are a lot of other cloud solutions like Microsoft Azure, as we discussed earlier, Amazon Cloud. They also offer a lot of APIs. Probably few initially they are free for be used, and it all depends upon number of usage and all that. So the charges are based on number of users, usage, and the memory and all that. But definitely the APIs are quite good. Either it could be voice recognition or it could be image detection. So you pass the voice file or image file, it will probably do the predict the particular values, and it will return back as part of an AI APIs. So these are a few solutions which are available in the market. Then these are few statistics with regards to different components within AI. Python is which is really on the top. If you look 3 years back, it had a market share of around 30%. Now it has almost doubled in 2 to 3 years, which is crossed to 50, almost 50%. Okay, so that's the kind of popularity or momentum which is gained by Python, and this is the basic reason why we use it, because a lot of companies. Ranjana, are you able to hear me?
Yeah,
Okay,
I'm able to hear you.
okay, good. So So if you look at Python, definitely this is one area which is quite hot in the market. As I said, there's a lot of community support, good amount of libraries, okay, and R is also good. We can always say R is also good, but definitely if somebody is new and if he's entering into AI, we would always suggest to go with Python, because R is one age-old solution which is used by most of the scientists, but probably they would might not like to shift into Python at this point of stage, so probably they might continue with R, but definitely for newcomers, it's always Python is recommended. And there are a lot of other tools, as we have discussed few of them, like SQL. We have RapidMiner. We have Anaconda, which will normally we will use this for installations and other stuff. Then you have TensorFlow. Scikit-learn is one of the famous libraries. We will be often using this library. Then you have Tableau, which is a good part of reporting, and a lot of other tools within this. Okay. Then let's look at a quick, machine learning life cycle. So basically, overall, the machine learning life cycle can be divided into two parts. First part is with regards to data, and the second part from step 4 is actually more focused on AI and machine learning. Okay, and the first three steps are common in any technologies or any other platform, where you gather the data, you do a pre-processing, you do cleansing of the data, and probably 60 to 70% of the time in the entire project in real time we actually spend here in first three steps. So once you have the actual data and the data which can be actually passed to the system, that's where we get into the machine learning part, like splitting the data into training, testing, and validation, choosing the right model, training the model, then doing the evaluation, performing the parameter tuning to it, and then deploy it, and then it gets into the managed services finally, which is part of the services. So this is the basic life cycle of machine learning. Now let's look at from different terminologies how exactly a machine learning would look from a bird's point of view or from a layman point of view if you have a basic programming background. We'll just try to see how it actually looks like. You basically have input data, and then you have few algorithms within the machine learning, and it will give you an output. Okay. Now, if you look at the data, this is how assume the data. This is one of the famous data sets within machine learning. This is the Titanic disasters data. So this data actually contains, information about the passenger and whether he survived or he couldn't survive that incident. Zero is for the one who actually couldn't survive, and one who could survive that disaster. Okay. Now, if you look at this data, basically within machine learning, and within machine learning, you can have supervised or unsupervised. Now, this is actually a supervised machine learning problem because we have the actual input data. All these columns are input data, and the final one is the output data. Okay, so this is all basically you can call it as inputs or features, and the last one is output or a class, which is either 0 or 1. So if you have this last column, which is the output, which you need actually, then it becomes a supervised learning. If you don't even have the output, then your problem becomes an unsupervised learning. So you have different ways of implementing it and different algorithms for that. Okay, so I hope I'm clear with this part. Okay, so this is how it would look. You pass this data plus this data initially, and you train the algorithm. Once the algorithm fine tunes and gets trained, then in future you can only pass the first set of data, which is features. It will actually predict you the output. Okay, so just giving you a brief view and exactly how the programming you would basically that the concept will really look like. Then during the course, we will actually go through the back end of most of the famous algorithms which are being used. It would be probably linear regression. It is a very fundamental algorithm. So we will try to understand the algebra behind it, the statistical activities behind it, and try to find a solution out of it. Okay. So this is what we are going to do during the course. Okay. Now what I'm going to do is I'll just show you a quick demo on how this stuff basically works. Sorry. So here what I did is I've just taken an Excel sheet. Okay, and within that Excel sheet we are trying to solve a problem here. Now what is the problem statement? Is that we have a in a restaurant we have a bill amount. Some customer had paid 34, someone has paid 104, 64, $88. So this is the basic bills which he has paid. Now for that bill, he has also paid a tip amount. For 34, he has paid $5. For 108, he has paid $17, and so on. Okay. Now, based on this data, we will actually try to calculate the probability based on the billing amount, how much tip is going to get in future, which is based on the bill amount. Okay. Now for this, we will use a formula which is this particular formula in linear algebra. This is the formula for the line, and with that within this line you will always have a slope, and you will always have an intercept. Okay, so first thing is you find the slope, and this is the formula which is x mean, x of mean. So you take x value and y value, you take their mean values and you put those mean values within these formulas, and then you will get a value which is m. Okay, so this m will come here. X is nothing but your input. Yeah,
uh, just a minute. Yeah. What are exactly X and Y over here?
yeah, this is slope and intercept. This is
Of?
independent. I'll come step by step. This is a line.
Oh, okay, I get it.
Okay, yeah, this is a line, formula for a line, and this is your dependent variable. Y is a dependent variable. That is this one. Okay, It is dependent on what? It is dependent on X, that is your bill amount. Is that clear? X value and Y.
Yeah,
Okay,
yeah, yeah.
and this is the slope and this is intercept. Okay, so when you actually get the formula, you put, we already know what is this value. Okay, Y value, which is our dependent variable. Okay, so that you will put here. Okay, then you will actually find the value of M. This is the formula, and this formula we have done it step by step in the Excel sheet here. Okay, so once you get M value, once you get Y value, you already have the X value, which is the independent variable. Based on that, you find the dependent value. Okay, and this is all just the mathematics behind a formula. In real time you might not do all this stuff, but it is always good to understand the basic mathematics behind the process. Okay, then you will know exactly what algorithm to use, and how things would really work in the background. Okay, so I hope somebody joined the call. It's quite late. Madhav, is that you? Madhav, are you there? Are you on mute by any chance? You can also chat if you're not able to communicate through voice. You can always chat there. You will have a chat option. Anyway, I see he's joined, but I'm not getting a response. I could, yeah. So yes. So, Madhav, I think we are almost done. This actually class I have scheduled it for you, but we have another interesting chap, so we're just going through that. Okay. So it's quite at the end, but still I think you can quickly go through it. Yeah. Okay. Now, so just Mother, for your understanding, we were just discussing how we actually go through this. Okay. So we had covered a lot of stuff already. Uh, this is a problem statement. Okay. And we have a bill amount, we have a tip amount. Okay. And a restaurant owner wanted to know exactly what will be the tip amount for a given specific bill amount. Okay, and that we can do using probability. Okay, and one of the methods which you can use is linear algebra. Within the linear algebra, we use the equation of a line. Okay, so this is b equals to y mean minus m into x mean, basically. Okay, so I was just explaining what these different terms are. Okay, which is the independent variable, dependent variable, and why it is a dependent variable and all that stuff. But probably this is the mathematics which is actually behind finding the probability. Okay, so finally you will get a probability of around 74%. So this is the accuracy which you get it, because once you find this, you will have different SE, SST, and putting all those particular formulas here, you get a final value, which is the probability. Okay, but in real time, you will not do all this stuff, but it is always good to understand the mathematics behind it, so you will know how a formula is evolved, and probably in later formulas you will know by looking at this formula what that complexity is or how a particular value has been derived. Okay, so just for an understanding purpose, I have just designed this Excel sheet to just show you that most of the algorithms can also be implemented in an Excel sheet, as simple as that. Okay, you don't I will not say for everything, but most of the algorithms can also be directly implemented by using an Excel sheet, as simple as that. Okay, that's how simple it could be. Okay, so this is the basic formula which we actually use to predict the tip amount given a bill amount. Okay, now what we will do is we will try to implement the same thing in a Python program. Okay, here. So if you look at this program, we are trying to find the best fit line, coefficient of determination, and all that stuff. Okay, It would look bit cumbersome, okay, but definitely you are not going to develop formulas from scratch. Each and every formula is already available within Python packages. You're just directly going to use a particular package. Here what we did is we actually tried to break down that particular formula and just show you, how that formula would look if it is actually implemented. Okay. The same problem Excel which we did it, we tried to actually break down and try to implement in Python. Okay. Now if you execute this, see, I just executed this program and I got an output. And it is the same output which I got it here. If you look at slope, m value is 0.14. Okay. Then if you look at line intercept, this is the line intercept. Okay. And this is 0.49. It's the exact value which matches to your Excel sheet. Okay. So this is how I try to implement the same stuff. Okay. But definitely in real time, you don't need to worry. You'll not go through all this pain writing each and every formula. It's all available in different modules. Okay. So now we will look one step ahead. Okay. How it could actually be. Now this is a real time implementation which you do. Okay. So for everything, just I'm giving you again a clarity that libraries are available. Now, if you want to implement linear regression, you have a linear regression library. You just import that library. This is the step and you implement it. That's it. Okay. The actual code here is only 3, 4 lines. And first 2 lines is nothing but actually creating the data. Okay. But the core part is only 2 lines if you look at within the linear regression model. Okay, so we are actually creating a linear regression model. We are passing the x data, we are passing the y data, independent and dependent variables, and based on that we are getting a regression line, best fit line output. Okay, and for that you can also do prediction, and once you get it, once you develop the formula, this is actually your model. Okay, and then this is actually your prediction. You're doing a prediction for that particular model. Okay, I hope that clarifies, right? So this is how simple it could be. Here it's all printing part, so we are actually printing it in different aspects. So if you run it, if you see, I'm just trying to fill more, trying to print most of the parameters formulas into that. Okay, here you get the same output again. The same program, we saw it in Excel sheet, we saw it in the custom. If you try to really build your own formula, uh, which you will definitely not do it because you have everything available. So this is how it finally would look like, and this is actually your best fit line. Okay, now if you give any prediction, assume that bill amount is 95. So from here I'll go straight up. Okay, and probably if I match it to my tip amount, it would be around 12.25 or something of that sort. Okay, so if I predict that value here, so it will somewhere match to this. Okay, so this is how actually the program will really look like. Okay, now we can go one step ahead of this, one step further on this. You can actually do a good stuff in rapid miner. Okay, and I will show you one quick example in rapid miner, and that too in clustering. Okay, we'll see exactly what clustering and what the data is. Okay, now let's take an example. What we'll do is we will look at the iris set. Okay, now Ranjan, if you remember, we discussed two aspects. One is supervised learning and unsupervised learning. Okay, in supervised learning you have to pass the input data and also the output data, what is the predicted output. Okay, that is a supervised learning. For example, we have seen bill and tip amount. So all this part could be initially the bill amount and the final output could be a tip amount. Okay, so that is all supervised learning. Now in unsupervised learning you will not even have the output. Okay, because what we are doing till now in supervised, we are giving input and training the machine, telling that if this is the input, the output should be this one. If this is the input, output should be this one. That is supervised learning. Okay. In unsupervised learning, you will have input, but you will not even have this output. So that you have to train the system in such a way that with the existing data it gives you the output. Okay. And we'll try to do that part here with a GUI tool, which is the rapid miner. Okay, now this is a rapid miner tool. What I will do is I will actually import this data. Okay, so if you look at, I have removed the final column, which is the label, which is called as a label output. Okay, now you just have numbers here, nothing else. Okay, and the problem is you have sepal length, which is related to a flower, sepal width, petal length, and petal width. With these numerical terms or measurements which we got it, we will try to predict an output, which is known as an unsupervised learning. Okay, so we'll just import this data and try to predict what under what clusters or what segment it will fall in. Okay, we'll try to actually segment or cluster flowers based on this data. Okay, so what I'll go is I'll go to rapid miner. Okay, and I'll try to import this data now. I'll import it from my computer, data, iris, this one. Okay, and if you look at, these are the 4 columns I have imported. Okay, then I'll say next and next. I'll store it somewhere. I'll say overwrite. Okay, so now I have the data here. What I'll do is I'll drag and drop the data here. This is my data. Okay, now we'll do a clustering. We'll use a clustering algorithm, which is a k-means. We'll use a k-means clustering algorithm. Drag and drop here. You do a connection. Uh, you connect it to the output. Okay, and you execute this. Okay, now I'll expect a response from you guys. By looking at this output, can you tell something? Just try to understand what this output is. Ranjan Madhav, can you just I know it is too early for you guys to say something, but just try to understand this input. Do you see any difference, or can you observe something in this output?
Well, it's is it trying to detect which cluster does it belong to?
Yes, you're right. We actually used 2 clusters. That was actually wrong. We should have actually used 3 clusters. Okay, because they were actually 3 segments. Okay, because we know it, because that's what it is. Okay. Now let's look at the data. Now this was your input, right? And this is your output. Okay. Now let's look at the actual data. What input and what is the output? If you would have done a supervised learning. Okay. So look at all this iris setosa till it's all segmented based on its length. Till 50, it is all setosa, right? Now from 51 to probably 100, it will be versicolor. Okay, probably 101. Sorry, 100. This one. Then Virginica, which is the third cluster. Okay, we have not passed this data. You remember, we just passed only mathematical values. That's it. Okay, and let's see the output, what it has gave. If you look at the compare with actual output. Okay, cluster 2. Okay, you have to interpret the naming conventions, because this is randomly generated by the system. So probably from 1 to, it's all say cluster 2 till here 50. Okay, does it make sense if you compare with an Excel sheet? So that algorithm actually worked on this particular parameters, and it has put whatever parameters falling, and because we have mentioned 3 clusters, it will create 3 clusters. If you create 2, it might create two clusters. Okay, so it has been divided into three clusters. So first till 50 it is all identified as 2. Next, most of this is identified as 1, cluster 1 till 100. Okay, and probably the last one is 0. Most of it is. Okay, but if you see, in some areas it is not properly identified yet, right? It's not 100% accurate, but still most of the stuff it has already given you that particular amount, and that is all nothing but probability. Okay, so in any machine learning problem you will get a output in terms of probability as part of statistics. Okay, it might not match 100%, but you can fine tune the data, you can tweak it and use some other algorithm and see, and or do a lot of repetitive tasks on this, or you can use combination of some other algorithm to get this particular output or improve the output. Okay, because it's all probability, and that is the kind of power. If you see, it would really look magical if within, if you pass these numbers and it is actually giving you some kind of a prediction. So that is quite tremendous, and probably we have just run it once, and probably if you do it in deep learning, or if you run 100,000, 10,000 times, probably in real time they might run it thousands of times. So it's, with so many iterations, it's keep improving itself. It's keep developing and improving itself. Similar to a Tesla car. If you look at Tesla car, it has its own algorithm, and most of the cars which are running around the world, they actually pass the data back to the Tesla server on a daily basis, and the algorithm keeps learning by itself with the new data which comes into it. Okay, that's all part of the deep learning. Okay, so this is what a quick demo which I just quickly wanted to give you and show you, how a basic machine learning or an AI part would really look at. Okay, uh, so do you guys have any basic questions? I'll just go ahead and at least stop the recording part. I think we're done with this. Okay, but meantime, do you have any questions? Please do raise it.
So image recognition is also done in a similar way, like millions and millions of